Alright, this is a video. I should have started the video up here. It's the limit. Limits at infinity. This little fancy symbol here, the one that you see in the TV show Revenge, which by the way was one of my favourite shows, and I'm not even ashamed to admit it, even though I am a male, nevertheless. There's 3 cases, from what I know. Let's just say that the power of the highest degree terms in the denominator, as you can see here, x to the 5th over x cubed plus 1. It's going to go to the infinity, and here's why. Because this value, let's say we plug in 5 as our value for x. By the way, it's the limit as x approaches infinity of this, and this is also the limit. And I know that my I made a mistake here. Look, I make mistakes, man, all the freaking time. So the limit as x approaches infinity of this equals infinity. How cool is that? It can equal an idea that's not even really a number. Infinity is not a number, it's an idea of some ridiculously big number. We can't even fathom, because we can keep counting forever and ever and ever. But here's the idea. If we plug in some really big number here, let's just say like this value reaches 1,000,000, like the biggest number in the world. Let's just say that this reaches the biggest number that you can possibly think of. It'll reach it before this one does, which means that this value of x is going to keep growing larger and larger and larger and larger and larger, as opposed to this, and therefore it's going to go to infinity. And I can prove that algebraically, which I will in a second. I'll prove both of these algebraically. Now the power of the highest degree terms in the denominator. So as you can see, x cubed plus 1, I'm just reversed it, so x cubed plus 1 over x to the 5th. That equals 0. Because this, let's just say that these both reach the biggest numbers that they can possibly reach. Like they both reach the same number, obviously, so we're approaching infinity, right? So this isn't going to be different to this. They're both approaching this, like they're both using the same x value. But the denominator is always going to be larger. Even if you had a coefficient on x cubed like 7 or 100 or 1,000, doesn't matter, because the power of x to the 5th is going to reach an exponentially larger number regardless of what power, because of the power of the exponent. It makes the biggest influence. And this plus 1 plays like literally no role in determining where the limit approaches. So that's why it approaches 0. So basically the idea is if you have a higher power in the denominator, it approaches 0. In the numerator, infinity. If they're equal to each other, the numerator and denominator, you can actually solve it usually. But I'm going to prove this one right here. So let's just say the limit as x approaches infinity of x to the 5th over x cubed plus 1. Now we're going to do a little bit of algebraic manipulation here. So let's just rewrite this. This is now the limit as x approaches or tends to infinity of x to the 5th over x cubed, and I'm going to factor that out, so it's 1 plus 1 over x cubed, because when you think out that's x cubed plus 1, if I multiply it back out, which means that this cancels with this, and this is therefore equal to the limit as x approaches, and that's how you solve every single limit problem, by the way. That's exactly how you do it. You factor out the highest power term and you cancel them out. That's the coolest thing on the planet. So now, what's 5 minus 3? Well, that's 2, yes? That's x squared over 1 plus 1 over x cubed. Well, what's going to happen here? If I plug in infinity, that's infinity over 1 plus 1 over infinity. Well, 1 over infinity, if you recall, if the highest power degree term is in the denominator, that goes to 0, which means that this guy goes to 0, and this is infinity over 1, which is infinity. And that's the proof as to why that the first one goes to infinity. It's not really a proof, it's just like a way of thinking about it. Now let's prove the second one. So the limit as x approaches infinity of, well, what was the original function? That was x cubed plus 1 over x to the 5th. We're going to use the same idea, yeah? So that's we're gonna rewrite this as the limit as x tends to infinity. I changed it up on you. And now that's x cubed, factored out, 1 plus 1 over x cubed over x to the 5th cancel, and that's just equal to the limit as x approaches infinity of 1 plus 1 over x cubed over x squared. So this is going to go to 0 because the power of the highest degree terms in the denominator. So this is like 1 over a million, and that's effectively 0. Yeah, like imagine 1 over a million is like the smallest number ever, or 1 over a billion. This is 0 basically, and that's 1 plus 0. So that's 1 over, and infinity squared. That's like a million squared, for example. 1 over a million squared. That's also 0. Which means that this is going to approach 0. And that's why that function approaches 0. So rather than just thinking about it, you can prove it if you really wanted to. But that's the basic idea of limits as they approach infinity. Basically, you factor out the highest power term, and then you cancel them out, and then you plug in infinity, and you make the conclusion of whether or not it approaches a certain value. And it's not always going to be infinity or 0. It can actually approach a number. In the next video, I'll probably demonstrate that concept of what the idea is. And I'll explain 2 different ways of doing it, and then I'll explain the shorthand way of doing it if you don't want to do the algebra. And that's the end of the video. Thanks for watching. This is Limits at Infinity.